All right, this is for Haley, 7-6, geometry. This is the last section of the chapter. Parts of,
Wait, what?
I know, I'm mentioning it now. So tomorrow we'll start review over chapter 7. This is crazy.
I'm gonna be gone
Crazy
tomorrow.
nuts. Crazy nuts. I'll give you the review.
Wait, you're gonna be gone for what?
Okay?
Speech.
Conference speech, yep. And who else is gone? Evan, are you gone tomorrow? Yes. You're going to CCC. John Deere or something? No, that's not you? Okay.
That might be.
I thought it was in the email.
Yes, you're gonna be gone.
I don't know. Anyway, I'll check my email again because I thought your name was on it.
Well, level 1 maybe.
Oh, but you're not going. Okay, so that's why your name was on it, but no. Okay, so 7-6 parts of similar triangles. We've only got 3 examples. We'll rock right through them, and here's how this works. Okay, so we have 2 triangles that we know are similar to each other. So let me say that this is 8 and this is 4. Okay, so the small one is half of the other one, and I'm talking about this as being a side and this as being a side. So 8 and 4 is what we have. Okay. Those are similar triangles. We know that they're proportionate, okay? Now, we have 3 sides of a triangle, and not only are the 3 sides here proportionate to the 3 sides here, but we can talk about the parts inside of this triangle. So, like, let's talk about this guy right here. These 2 guys. What are those guys called? Do you remember?
I don't know.
He's straight down, perpendicular with the ground.
Oh.
What's that called?
I don't know. I don't remember what it's called, but I remember.
Starts with an A.
The airplane one?
Yeah, the airplane one.
Oh, what? Oh, altitude.
Altitude. These are altitudes, okay? So, not only are the sides in the same proportion, but like, let's say I gave this and I said that this was 6. What would this guy be? The altitudes have the same proportion as what the sides do. So any of the inside parts will have the same proportion. So if the altitude is double the other one, you can, or if the sides are double, the altitudes are also double. Does that make sense? Any of the parts that you do, okay? So let's go down to this one. What is this little line right here and this little line right here? Those aren't altitudes because they're not a 90-degree angle. Look at the markings. What are they doing?
Angle bisecting.
They're bisecting the angles. So these are angle bisectors. Angle bisectors. Okay? So not an altitude, but an angle bisector. So like, let's say I say that this is 8 and this is 6. Like this side is 8 and this side is 6. And I say this guy is 3. That angle bisector is 3. Then this guy is going to be 4, right? Okay, so not only are the sides of the same proportion, but the angle bisectors are the same proportion as well. Okay, now, before I move on, Jake Hodson made this observation. I was like, that's kind of brilliant. He said, if this is an angle bisector and this is an angle bisector and they're similar triangles, these 2 angles will be the same, right? And these 2 angles will be the same. But if they're similar triangles, won't all 4 of them be the same?
Yeah.
Because we've talked about that before. Like if this is 20 and this is 20, then this isn't 40 and 40, right? They're exactly the same angle. So he's like, why did they mark it with 2 markings instead of 1 marking? And I'm like, I have no idea. They should technically be 1 marking, right? Because all 4 of those angles should be exactly the same. Because angles stay the same, but the sides are a different proportion, right? So that was a good observation on his part. Those should only have 1 tick mark for each one because they are exactly the same angle. Okay? All right, let's go to the next one. This last one. What is this thing called? He's going from vertex to the midpoint. He's going from vertex to midpoint, right? How do you know that that's the midpoint? The little tick marks tell me that those 2 pieces are the same distance apart or the same thing. So that's a midpoint. What's it called when you're going vertex to midpoint? What's that thing called? Like, what is this line called? It is. It's a median.
What the heck?
A median. Median means middle.
I don't remember.
Median is middle, so median is like midpoint, I think. So median, midpoint, vertex to midpoint is the median. Okay? Now, not only are the sides in the proportion, but if they draw a median, the medians are going to be the same proportion. Should I put numbers on here or not? No? So they're saying this is actually a really nice section to me because whenever I see lines and a whole bunch of triangles, this tells me that no matter what lines there are, like angle bisectors, altitudes, whatever, they will be in the same proportion. So that actually makes my job easier because I don't have to think about it. I know that every line, if two triangles are similar, I don't have to think about, are they the same or they're not the same? They will be in the same proportion. Any of the parts. It just makes life almost easier, right? Okay? All right, let's go down here. They kind of twist these shapes around on us, but it's fine. What is this little line right here? What is he? That's an angle bisector, right? Okay, and we know that if they bisect the angle, and we know to start with that those two triangles are similar to begin with, right? So we can set up proportions, and an angle bisector we can set up the proportion with as well, right? Okay, so all we have to do is what over what equals what over what, and solve for x. 15 over 12, okay? Those triangles are kind of reflected and twisted around and stuff, but 15 and 12 go together, and then what? X over 8, because you're going left to right and left to right. So, 12x equals, you know what 15 times 8 is?
No.
What's 10 times 8?
It's 120.
Is 80 plus 40. Do you guys do that?
Yeah, I was starting with
Yeah, I did it in my head.
Did you do it in your head? No? Oh, you can do that in your head. 10 times 8 is 80. 5 times 8 is 40. 80 plus 40 is 120, right? That one's not too bad. You can do this in your head. You better not have used a calculator. You did.
I did not.
Oh, okay.
I did not.
I was going to hurt you. 10 is x. Yeah?
Yeah.
Good? So, any of the parts can be proportionate as well. Okay, let's go to this one. I like this diagram. Liliana holds her arms straight out, and this is where her thumb is located, and her eyeballs are like right here. And the first period class says, I hope her eyeballs are not proportionate to the cars. Like, woo! Her eyeball is like half of the size of what a car is. Dang. Woo! Anyway, so we've got these things going on here. And she holds her thumb straight out in front of her, and it says that her eyeballs, the distance between her eyeballs, if you take that times 10, that will be the distance between her like nose and her thumb, right? So it's not to say that this is like 10 inches. If you hold your thumb out in front, that's not 10 inches. That's going to be way longer than 10 inches. But what it's saying is that whatever this distance is, let's call it x, this is 10 times that length, right? So this technically should be like 10x, right? Mm-hmm. That's just 10 times as long. From here to here is 10 times as long as it is from here to here. Okay? So if your eyeballs are like 2 inches apart, from here to here would be 20 inches. That's probably pretty close. I don't know.
Should we get the
Measuring stick out.
The one that Kyle broke?
I have a big nose, so we got to go by like right there. Okay? How far?
Like about 20. I'd say about right at 22.
Right at 22?
Yeah.
Okay, so my eyeballs would be 2.2 inches apart. I don't know. Do you go from the middle of your eyeballs? I don't know. 2.2 inches? 2.2 inches apart, right there. That's how far, like the middle of the eyeball to the middle of the eyeball. Maybe something like that. Hey, now, you guys know that this is a thing, probably, right? Like if you hold your thumb out and you point it at something and you close one eye, like it moves. Okay, let's do this. Do you know what eye is dominant? You shooters, if you're a shooter, if you're like a hunter or a trap shooter, anything like that, you know, right? Okay. So like Kyle, I think Chase too even said that they write with their right hand, but they are left eye dominant.
Yeah,
Which is kind of weird. Okay, so here's what I want you to do. Do this. Go and stick your thumb up on the clock, and I want you to close. No. Just put your thumb up on the clock. I can't do this. Put your thumb up on the clock. Okay, I want you to close your right eye, close your left eye. Close your left eye and put your thumb on the clock. Close your left eye and put your thumb on the clock. Okay, now, switch eyes, does it move? This is what she's doing. She's doing that with the cars, and the cars are jumping, okay? Now, if you want to know which eye is dominant, here's what you do instead. Ready? You go like this, and you make a triangle with your, thing, and you put the clock in the middle of your triangle, right? Okay? And you hold both eyes open. Oh, I don't do it that way. I don't do it that way. Because I can't go back. Okay, so this is how I do it, because this is like idiot proof, because I can't do the whole like I go back to the center and I'm like that didn't help. So I put it in the middle, and then I close one of my eyes, and whichever eye I leave open, if it doesn't jump or cover it, then I know that that's eye dominant, right? Okay, so I close my left eye, and the clock does not move for me, which means I'm right eye dominant. But if I close my right eye, the clock is completely hidden by my hand. Does that make sense?
Yeah.
Yeah. That's how I do it. I can't do the whole like bring it back because I don't know. I'm like, whatever.
I started.
So anyway.
The thing is with me, like I started off as left-handed, but when I was in kindergarten, I had to switch. They made me switch.
Yeah.
So then I started writing with my right hand.
Oh,
But
nice.
there's other
But are you left eye dominant?
Yeah, I'm
There you
left
go.
dominant, but there's also like a lot of other things that I just do with my left hand and it's just natural.
Yeah. Yeah.
Mrs. Schroeder made me right-handed.
Yeah.
Yeah.
They made
We
me
live in a
right with my right
I
hand.
know. It's so hard being left-handed. I'm not left-handed, but it's hard for a left-handed person to live.
I finally learned that my
I know.
dad's left-handed. He had to sign papers. Now he's like, what?
I know. Yeah. Right. Okay, so what's happening is when she holds her thumb out and she closes her left and right eye, the car jumps 4 places, okay? So if I'm just looking at this like tire right here, if I'm tracking this tire, it jumps 1, 2, 3, 4 places to get to where the tire is now, right? Is that confusing? So yes, there's 3 cars in the middle, but from one to the other is 4 jumps. Does that make sense? Okay. And each car length is 5.5 foot wide. Okay. So 5.5 foot wide means I'm jumping a total of 22 feet. If you go 4 lengths of a car, 4 times 5.5 is 22 feet. They want to know what the distance between her thumb and the cars are. That's the X that we're solving for. So we can set up a proportion. And we know some things. We know that the distance between our eyes is, like, if you multiply that by 10, that gives you the distance from your eyes to your thumb, okay? So let's do something over something equals something over something. What would you like to do? X.
22.
Okay, X over 22. Which X are you using?
Oh, like, just like the
This X right here?
no.
No,
X.
no, this X over here.
Yeah.
X over 22 equals 10X over X, right? Okay? Oh, we got lots of X's going on, but I'm going to do this. I'm going to do this. Ready? I'm going to cancel these X's out. So what number's on the bottom? 1, okay?
I
So
was just gonna ask you if you could do that.
you can totally do that. Yep. So 22 times 10 is 220 equals 1 times X or X. X is 220, which should make sense, right? If the distance from here to here is 10 times the distance from here to here, the distance from here to here is 22, so this should be 10 times that, right? 220. 220 feet is how far her thumb is away from the cars, roughly. Okay? All right, last thing is talking about a triangle angle bisector. So, in all of these other proportions, we were only doing 2 triangles. Here we only have 1 triangle. 1 triangle, okay? And what they're doing is for this 1 triangle, they're saying, even if you only have 1 triangle, if we bisect the angle, which means split it in half, okay? Let's say I have this guy is X, this guy is Y just from here to here, this guy is Z just from here to here, and this guy is W from here to here. You see the little sides, okay? What I can do is I can say X over Y equals W over Z. I can say this over this equals this over this, right? And that is only for 1 triangle. I'm not comparing 2 triangles, but the angle is bisected, so the distance from here to here should correspond to the distance from here to here. And the distance from here to here should correspond to this distance. Now I just made a mess of that thing, but does that make sense? You're doing proportions, and they're proportionate, but that's only for 1 triangle. So lots of similarities show up. Okay, good? All right, let's go down here. So still only have 1 triangle. I am dealing with an angle bisector. Okay? So take a look at this. This side right here, this one is bigger than this one, yeah? Right?
Yeah.
So what should be true is that this little piece right here is bigger than this little piece. Does that make sense?
Yeah.
Okay? Which is true. We can see that, right? Okay? And they're the same proportion, so we can use this to solve stuff, all right? So,
6 over 14.
okay, so let's do 6 over 14. Okay, 6, 14.
X over 18 minus X.
Yeah. So a lot of people were saying X minus 18. But this little bit right here from here to here is 18 minus X. Whatever the X is. Let's say X is 3. Then that would be 15 because you're taking 18 minus X. So just be careful of how you're adding, subtracting. And then we just distribute. Or, hey, let's do what Libby does. Let's do what Libby does because we like to deal with small numbers. 6 and 14 reduce, right? If I divide by 2, that's 3 and 7, okay? We can reduce that and make it smaller numbers. Then it's easier for me to deal with. So 7 times X is 7X. And then 3 times those guys. 3 times 18. 3 times 10 is 30. 3 times 8 is 24. So 30 and 24 is 54. Minus 3x. And then let's just add the 3x plus 3x. That is 10x equals 54. X is 5.4, which is true. And they don't have dimensions, so they just say find x. There you go. Okay?
Swag.
Beautiful. Very
That
short.
was really fast.
Very short. Do you guys have the homework? All on practice?
Ew.
Ooh. All on practice.
And then.
And odds on skills.
Okay.
All on practice, odds on skills.
There's no story problem.
There is no story problem. Yeah, so very nice.
There's 2 story problems.
Very nice.
I always
Very
question
nice.
myself now that I have a marker because I
Okay.
keep thinking I'm going to mark off the wrong
Story
thing.
problems. Yeah, there's an A and a B.
There were?
There's 2.
Ah! It's fine. I'll be alright.
Why would you do
Yeah,
Hey,
wait.
I mean, at least we get a hit
Uh-huh.
on A.
Alright. Bye, Haley.